on solubility. In this lesson, we're going to be looking at the comparison of solution processes in water and molecular substances and ionic compounds, just like before, but in more detail. So specifically, solubility. Well, solubility is the measure how much of a substance, usually a solute, so usually a solid, will dissolve in a given amount of solvent. So for example, sugar is your solute and it's very soluble in water, which is your solvent. There are three types of solubility that we're going to be talking about. There's unsaturated, where you can dissolve more solute in your solvent, so it's not completely saturated with solution with your solute. There's saturated, where we have the maximum amount of solute dissolved in our solvent, and supersaturated, where we have an unstable amount of solute dissolved in our solvent. So here you can see more solute will dissolve, so more of the sugar cubes will dissolve in the water. No more sugar cubes will dissolve, they'll stay hard sugar cubes. However, if we heat the solution there, we can add more solute, which means we can have a greater amount of solute present in our solvent or solution. So there's three types here. You can see this is an example of supersaturated. We've dropped a crystal in, it's been heated up, we have therefore more of the solute dissolved in the solvent. If we then place another crystal in there, or we shake it, those crystals will precipitate or come out of solution. So again, this is the process of supersaturation, how it works. Saturated solution there is heated. When it's heated, you can add more, clearly you can see more solute molecules here, and then we cool it down slowly and those will still stay in solution. So we still have a clear solution as in here. However, when we place a crystal or we give it a shake, that will precipitate out the solute. Now we're going to talk about solubility curves. Solubility curves are a useful way of determining how saturated a solution is. So at higher energy or at higher temperatures, the solute and solvent have more kinetic energy to overcome the forces of attraction holding them together. And that describes why we can create supersaturated solutions. And that'll come to your understanding when we look at solubility curves. So clearly, as you increase the temperature, you can dissolve more solute in that particular solvent. So let's take a look at a solubility curve. It describes the amount of solute which can dissolve in 100 grams of a given solvent, and that's usually water. So over here, we have sodium nitrate in the yellow, and we can see that at 10 degrees Celsius, we roll up from the curve, we have about 84 grams of solute dissolving. Again, if we look at 40 degrees Celsius for sodium nitrate, you can see that you have a greater amount of solute dissolving per 100 grams. So here we have about 105 grams of solute dissolving at 40 degrees Celsius per 100 grams. So any point where the temperature matches the line, that's known as saturated. So these 2 points here, they are saturated. Anything below, any amount of solute below that is called unsaturated. And anything above that, over here, is supersaturated. Let's do an example of calculating the amount of solute of sodium nitrate in 100 grams of water at 50 degrees Celsius. So we draw the line up, 50 degrees Celsius. From there, we match it across. We can see that 120 grams of solute will dissolve in 100 grams. So there's 120 grams of sodium nitrate in 100 grams of water. Let's do another example, calculation. So we have an 80-gram sample of sodium nitrate, and that's added to 200 mils of water at H2O at 20 degrees Celsius. So let's use this figure to help us calculate how much more sodium nitrate can be added to make the solution saturated at 20 degrees Celsius. So first of all, we rule the line at 20 degrees Celsius up to the curve, and we can see that we have around 92 grams of sodium nitrate will dissolve in 100 mils or 100 grams. You can use these interchangeably for water. So water, 1 gram is equal to 1 mil, therefore 100 mils is equal to 100 grams. Only for water this is true. So we have a saturated solution at 20 degrees Celsius of sodium nitrate is 92 grams of water per 100 mils. The amount of sodium nitrate which can be dissolved in 200 mils of water is 184 grams because we have twice as much solute can dissolve in twice as much solvent. Now, if we want to work out how much more solute, sodium nitrate, can dissolve in 200 mils, we simply subtract the total maximum amount that we have. And so here's the total amount we could have. 184 grams is the maximum amount we could have in 200 mils. We have 80 grams as listed in the question here. So we have 104 grams, which is remaining to dissolve. This is just a process of how solubility curves are determined. This is what you should be able to do: explain solubility and the terms unsaturated, saturated, and supersaturated, and use solubility curves to identify levels of saturation and calculate these levels of saturation. These are the questions to complete. Thanks for watching.